What's going on, everybody? Welcome back to the channel. I know it's been a minute since I've made my last video, but I'm back and I'm looking forward to making a lot of videos here in the near future. As you can tell by the video title and thumbnail, I'm going to be going over the formulas I've been using for the strikeout method or system, whatever you want to call it. But I posted a video on it a while back at the beginning of the baseball season, and I've had a lot of comments reaching out asking for kind of the details of the formulas that are included in it. So I thought it'd be good to make the video and kind of let you guys know what I have been using stats wise. So jumping into the first formula that I look at for picking strikeout props over the course of the past couple months is the K9 conversion rate. It's a pretty simple formula, so it's not worth spending a ton of time on. But basically, I take the average K9 and compare it to that specific pitcher. So you'll see Charlie Morton's K9 is 8.4 and the average is 7.7. So I use that kind of conversion to determine, based on the average pitcher, Charlie Morton's going to have about 1.09 strikeouts to the average one strikeout that the average pitcher would produce, which kind of appropriately adjusts the total for Charlie Morton's ability to strike out batters. Next formula that I look at is the total batters face, which kind of explains itself, but it's just the number of batters that the pitcher is going to face in his outing. As you can see, the first bit of the formula goes over the projected innings pitch. So you'll see 3 times K8. K8 is the cell that has projected innings pitch. So in this example, Charlie Morton is projected to throw 5 2/3 innings. You multiply the 5.67 times 3, and that's the number of outs that he's going to record during his outing, which is about 17 outs. So that's 17 of the 24 batters. The next aspect of this formula is taking into account the number of walks that the pitcher is going to have in his outing. So I take the K5 cell, which is the walks per 9 innings cell, which Charlie Morton averages about 3.2 walks per 9 innings pitched. And I multiply that by the projected innings pitched and divide that by 9. So the innings pitched divided by 9 gives you a number or a ratio that is used to multiply the walks per 9 innings. So because that's the 9 inning formula for walks, it's at 3.2, and you got to take the ratio of innings pitched divided by 9 innings to get the proper number. So it would be, 3.2 times this number would be 0.6. So that number is also factored into the total number of batters faced. And then the final portion of this formula is the number of hits that the pitcher is going to give up. So for this example, Charlie Morton's going to give up 8.5 hits for every 9 innings he pitches. And similar to the walks, because it's on a 9-inning basis, you have to take into account the number of innings he's actually going to pitch, because very rarely do pitchers throw 9 innings in an outing. So the 5.67 divided by 9 to get that ratio and multiply it by the hits per 9 gives you the last bit of the total batters faced. Now, I can see how this formula would get a bit complicated when you're throwing around these ratios and number of innings pitched, but this is just to give you a general idea of the total number of batters that the pitcher is going to face in this outing. So if Morton wasn't to walk or give up any hits, he'd face 24 batters and would have a chance at recording 24 outs. Ultimately, this is going to help you determine the chance of him striking out a certain number of batters, right? So if he's going to face 24 batters, then he's going to have a chance to strike out X number of batters, versus if he's going to face 27 batters in an outing, then his chances of striking out, another 1 or 2 batters goes up due to being able to face more hitters in an outing. So this is just kind of a rough idea to see how many guys are going to come up to the plate against him and what are his chances of striking each of those guys out. The next formula that I look at when trying to predict the number of strikeouts is the number of at bats a hitter is going to have in a given outing for that starting pitcher. So, in this example, you'll see that on average, a hitter is going to have about 2.71 at bats per hitter. Now, I recognize that a hitter can't have a fraction of an at bat, so that just kind of determines how many hitters in the lineup are going to have 3 at bats versus 2 at bats. So that meaning if Charlie Morton's going to face 24 batters in an outing, that means that he'll be able to go through the lineup fully twice. So that's 18 batters going through the lineup. Twice is a total of 18 batters. Then that third time through the lineup, he'll be able to face 6 more batters. So the 1 through 6 hitters will have 3 at-bats, and the 7, 8, 9 hitters will have about 2 at-bats, because at that point, Charlie Morton will likely not be in the game. All of the pitcher stats out of the way, we can take a look at the hitter's likelihood to strike out in a given at-bat. So if you take a look at the formula, you'll see that it's a complicated if-then statement. All this means is that if the number of batters is greater than 18, the hitter will have 3 at-bats in a game, and if it's less than 18, they'll have 2 at-bats in a game. Now, this formula is different for each batter, but it's only different by one number. So for the first hitter, it's 18 because he'll be that 19th batter in the order. For the second batter, it's 20, third, 21, and so on, just so it can help determine how many at-bats a given hitter will have in a game. So once the number of the at-bats for that given hitter is determined, you're going to multiply that by their strikeout rate versus that given pitcher. So for this specific example, Charlie Morton is a right-handed pitcher. And for the first batter, it's B19. In cell B19, it'll show that Shohei Ohtani has a 26.4% strikeout rate versus right-handed pitchers. So he's going to have 3 at-bats because Morton's going to face 24 batters in the game, which is greater than 18. And then you're going to multiply that 3 by 26.4%, which is going to give you a strikeout of about 0.792. So that means that in 3 at-bats, Ohtani's going to average about 0.792 strikeouts in that game. Now, again, I get you can't have a fractional value for strikeout. You either strike out or you don't. But the sum of these strikeout numbers will give you an overall projected strikeout line that will help you determine whether you want to take the over or the under for that specific prop. The last formula that is relevant for this model is the final projected strikeout line. Now that we have all the stats in place and we kind of understand the flow of everything and how everything kind of works together, we can come up with a final projected strikeout line for that pitcher. So if you take a look at the formula, all it is cell K14, which is the K9 conversion rate. So for Charlie Morton, it's 1.09, and you're going to multiply that by B35, which is the sum of all the total projected strikeouts for the hitters in that lineup for that given day. So in this example, it would be 1.09 times 7.211, which gives us that 7.8 number of final projected strikeout line. And as you can see, the line for the given book that I was looking at was 8.5. So since it's 7.8, that number is under 8.5. So I'm going to take the under 8.5 at minus 138. And it's that simple. Once you become familiar with it, it's just a matter of plugging numbers into the Excel sheet, and it'll just spit out an answer for you. It takes relatively no time at all, but it is kind of a pain to break down and understand and put it into an Excel sheet. If you guys would like me to share my Excel file, I'd be willing to do that. And if you have any questions, definitely leave them in the comment section down below this video. But if you like the video, definitely give it a thumbs up. And if you're looking for more kind of instructional videos like this and just general pick prop videos, coming out in the near future, then I'd definitely hit the subscribe button, and I'll see you guys in the next video.